clicker. Cool. Hey everyone. Thanks for staying for the last talk before lunch. I really appreciate it. I know it's been a long morning, but we're nearly there. I work as a developer at Hive, which is a smart homes company back in London. And some 3 years ago, we decided to start using React Native for our applications on native devices. And this talk is about how we took our code from web to React Native and then back again. First things first, though, why did we actually choose React Native to begin with? It's not an obvious choice, especially since a lot of people say, things like the performance isn't great. Why are you even thinking of using JavaScript? So let me reiterate why we decided to do it. At Hive, we have Internet of Things devices. We make them ourselves, and we have a wide range: thermostats, cameras, sensors, light bulbs. And it's not just the number of devices, it's also the complexity, how they are interlinked. There are actions such as if you open a door, turn on the light bulb. There are schedules so that your home is heated up to a certain degree when you're coming home from work, that kind of stuff. So there's a lot of complexity, and I don't think there is a single person on our team who actually understands the business logic for all of our devices. I think it's impossible. Yet we do need to provide users with the UI, and this is a screenshot taken some 3 years ago from our 3 different apps. It was the web, Android, and iOS. And obviously, the complexity is huge if you just do it for one platform, but if you do it for 3 platforms at the same time, it suddenly becomes much harder. It takes a long time to develop for 3 different platforms, and it's just generally hard to manage to get things in time and to the same design consistency, text, business logic, etc. So we decided to use React as the one technology to rule them all. And you can see that I learned from Sunil yesterday morning that this is how you do the React logo, so, props to him for explaining it to us. But when you tell everyone at your work that you want to use JavaScript everywhere, people become really anxious. When I started developing front-end as a hobby some 15 years ago, a lot of people told me JavaScript isn't a real programming language, and there are a lot of people who still claim that, especially native developers. So when you say, oh, let's do React Native, everyone starts being really afraid. But the truth is that there is one huge advantage to it, and that is code sharing. The fact that you can share code between not only Android and iOS, but also with your web application is unbelievably powerful. It means that you can deliver features much faster because you don't have to develop them 3 times, but just once. That also means that you have lower costs for development, so if you want to sell this to your boss, this is the ultimate reason. And it's in a way easier to hire for it as well, because suddenly you don't need to hire an iOS developer, Android developer, and React developer. You just hire a React developer. And last but not least, the consistency across platforms in terms of design, how things actually work, and the text and translations is much easier to reach. So overall, a lot of large companies, at least in London, are converting to React Native for all of these reasons. But first, before I get to what we share as a code and how we do it, I'd like to talk a little bit about how React Native actually works and how we render components, because that's kind of important for the rest of the talk. In React Native, we have our application. It looks pretty much the same as any other React application. And it sits in a JavaScript runtime box, just like it would do in a browser. This JavaScript runtime box is wrapped in some native code that then actually puts all of the, renders the buttons and the UI. And there is a thin layer between the JavaScript and native, which is called React Native Bridge, and that essentially just takes data from one thing to the other. So it takes a blob of some data from JavaScript, passes it to native, and forwards as well. We as developers develop usually only the middle bit, the application. We don't deal with the React Native Bridge or the JavaScript runtime, and very rarely we touch the native box itself. But what happens actually with the components if I write them with JSX in the JavaScript? How do they actually get out there? And the answer is in the way React renders anything. You've got the application, and on runtime, it figures out from your state and from some sort of JSX that you have written what kind of output it should be. And it produces this virtual tree. So whenever there is any update to props or state, the virtual tree gets changed. And that is just a blob of data that you can take and use at any platform, theoretically. So what happens on web is that it gets changed into a DOM tree and gets rendered out. I have even seen someone controlling hardware elements with React, because you can actually define, how do I take this blob of data and use it for hardware. And equally well, we can use it for Android and iOS, again, in theory. If we look at how those two concepts work together, we've got the app that has the JSX and the state. The JavaScript runtime passes that into the tree, the data. Through React Native Bridge, it gets to the native side, and that's where React Native figures out how to render it out. So that sounds awesome, right? That means I can write one component and share it absolutely everywhere, and we can share everything like state management, etc. But obviously, nothing is ever as good as it seems on the paper. I was kind of wrong to assume that was the case. The reason why that doesn't really work is something I call the components cross-platform matching game. Let's have a look at the components that are natively available to us on different platforms. Let's start with web. We've got our anchor and paragraphs, span tags, etc. And all of these are created originally for websites that were supposed to be document pages. So the semantics is really important. Having titles and anchors and links to other pages is what we made it for. Then we sort of started doing these dynamic applications, so we started almost misusing these things for different purposes. And it works great, but the truth is that the tools we have are very different from mobile applications. If we look at iOS elements or basic components, we've got much more interactive or dynamic elements. There are scroll views and sliders, labels, date pickers, etc. And they are obviously quite far away from what we know from web. And then if we look at Android components, we'll see they are very similar. Like, again, we've got scroll view and buttons. But there are differences between the two platforms. For example, on iOS, we've got date picker for both date and time picking, because on iOS, that is a one event or one thing to do. Whereas on Android, date picker and time picker are separate entities. So already we can see that there are so many differences between the platforms. It's kind of hard to figure out, if I write down a div, what is that supposed to mean in Android, on iOS, and on web? And I guess we could somehow map the components. Let's say div would be a view and a paragraph would be text. But then we've got other elements that are not so easily transferable. There are things like h1. Obviously, I could say, OK, well, maybe that would be a text. But I'm already losing some information regarding accessibility and semantics and SEO, which obviously you don't need on mobile. But you start realizing that transferring one to the other isn't completely straightforward. And so React Native obviously made the choice not to actually enable us by default to reuse these things. They didn't want to make the decision for us of how we would map one to the other. So it's a bit of a painful thing, because we ultimately have to write UI again. So when we were going from web to native, we had to rewrite all of our components again using the native components given to us by React Native. So if we can't share the components themselves, can we maybe share the styles? And how many people here like CSS? Raise your hand. I find this so fascinating. I hate CSS. I hate working with it. I never understood it. And whenever I do this talk and I ask this question, there are so many people raising their hands. So that's maybe why the React Native developers decided to use CSS as styling tool, right? And it's standard CSS in JS. There are some differences. For example, you can see on the font size, there is only 30. There are no units, because we don't use units in the native world. There are some other bits and pieces, like everything is flexed by default in a column, not a row. But most of it is the same, and we can reuse things very easily between different platforms because we define them the same way. And there are styled components available in native world as well. And their performance isn't particularly bad, although some people say it is. So we actually decided to use them native and web as well. And they allow to reuse a lot of code very easily, a lot of styles. And that includes, so for example, if you have styles defined with units, it will automatically strip them out for your native components. So that makes it quite simple to reuse styles. It also enables you to use design systems and share variables such as color schemes, spacing, width, height, etc. So styling, interestingly enough, is something that you could use or reuse, share between the different platforms. But the main thing that I think is the best about sharing code is the fact that we can share business logic. As I told you, it's unbelievably difficult at Hive to figure out what things should be doing. And testing them is difficult because you have a hardware device that you have to have next to you to figure out if it actually works. So if you can write business logic once and make sure that it actually works across the board, it's unbelievably useful. There are obviously some difficulties because we are talking about native world, which has hardware integration. You integrate with things that you don't have on web, such as Bluetooth, Wi-Fi, microphone, camera, etc. So those are bits we still have to write separately. We sometimes need to use some native SDKs for integration with third parties, so we, again, can't actually reuse that code. But when it comes to anything that is in JavaScript, remember, we are running this app in JavaScript. It's not a web view. It's not transpiled. It's just normal JavaScript. We can actually reuse a lot that is just JavaScript. Anything that relates to state management, like so we are using Redux. So Redux sagas, reduces, constants, config, API calls, all of this can actually be very easily reused. That includes tests as well. So you can actually reuse a huge amount of things. And translations were very useful for us because that way we actually could ensure that you have the same text on all devices. So just to sum up what we can share business logic, translations, and some amount of design. What we cannot share, unfortunately, are components, any kind of native code that is relevant only to one platform. And one thing I haven't mentioned yet, but I want to talk about a bit, is routing. You can do routing in JavaScript in React Native as well, but it's very slow, so most people wouldn't do it. So routing is another thing that you cannot reuse. Although it looks like maybe we can't reuse as much as we would have originally hoped to, it still speeds up the development process so much that we would never go back to the way things used to be. So it's all good, right? But there are obviously some drawbacks to absolutely everything. And the drawback is that like the concept of sharing code is great, but how do we actually practically do it? And we made like a little bit of a mistake at Hive when we originally started because we assumed that having like several repos and moving code to like a shared folder would be enough. But it turned out that it caused so many issues, like the fact that dependencies were going wrong, that they were all different versions, different patterns were changing, and it was really unmanageable to actually share code. We would keep breaking web by working on React Native and vice versa, and we realized that we can't actually keep doing this. And there is one thing that could have saved us if we actually did it, and that would be a monorepo. That would have been the ultimate solution. Unfortunately, we didn't do it. And at one point, we started thinking about, like, maybe we want to now explore monorepo because that would really help us with sharing code between platforms. But then we thought, is it really necessary? We had this idea that maybe our website isn't actually used by that many users. And when we realized that actually only 1% of our users are web only, we thought there is no point in us spending a lot of time refactoring things in order to make them work for 1% of our users. That's not economical. At the same time, you don't want to just, drop off the 1% of users. It is still a lot of people. So instead of dropping it, we came up with a solution. That is the hero of the day. He's my colleague Jegosh, who created this whole idea of well, yes, let's just use React Native Web. And to us at first, it was this library nobody really wanted to even consider because it felt really dodgy. it does this thing for us. Well, you remember when I was talking about like mapping components is painful and we don't really know how to do it? Well, React Native Web simply decides it for us. It has implemented scroll views, flat list sliders, all of these things from native into web so that you can just write native code and then get a web package out of it. So this does not happen anymore, which is kind of cool. What React Native Web really does is you write React Native code, and then you simply compile it into a JavaScript that you can run on web. That means that you can run the same code on 3 different platforms. Plus, one really cool thing about what React Native Web does is that it optimizes the JavaScript really well. I think, like 95% sure, that currently Twitter is actually using React Native Web to create their website. They are not using it for native applications, but they're using it for the website because it's so well optimized. Another reason why React Native Web really was a great solution for us was completely unrelated topic, but I still think it's very cool and would like to share it with you. And that is our design system. We have developed a design system of components that you can use essentially like Lego-like building blocks. And we have implemented them for our React Native applications, and we even have a storybook, so we have some sort of repository of all our components that you can see. But the problem is that in a design system, you need to have a two-way communication. It's not just about designers giving us the components, it's also about us developing the library and being able to show to them what we have already developed. And that has been a really difficult thing because you can't just ship a React Native application with Storybook. It's so difficult to create and distribute native applications that it's not just as easy as a web design guideline system. And that's where React Native Web comes into play, because that enables us to take our component library and actually transform it into a website so that our designers can see what we have done so far. So this is how we actually share our components and a lot of sort of unofficial things with the rest of the company. So it's like magic. It's like a silver bullet, right? Like I write one thing only once, it happens everywhere, I don't have to write it 3 times. But there are always caveats. It is never true when somebody tells you that you write one thing and it's all for all 3 platforms without extra work. That never happens. The truth is there are bits like the hardware integration that we simply cannot use on web. So we started introducing a lot of if-else statements. If this is web, just skip this bit that does like all the hardware stuff. We also have some native components that haven't been defined by React Native Web on web. So we actually have to create those translations or mappings ourselves. The same thing goes for routing and some other bits and pieces that come to do bootstrapping, because the way you bootstrap a React Native app and a web app are simply different. But it still means that vast majority of our code base can now be reused. We don't have to write things, not even twice. We just write them once. Very minimal amount of work needs to go into using it across the board. And now I have decided to be a little bit brave and use the rest of our time before lunch for a demo to show you how it works in reality. I've got our application here. It's a bit cut off, okay. And this is like the real thing, so I'm hoping that it won't actually like break too much. And you can see this is our React Native Web application. You can see that they are quite similar. And if I go from like one to the other page, it sort of like scrolls smoothly as well. And the nice thing is that we didn't have to do any extra work. We literally ran a script and we got this out of it. And that's impressive considering how much time we spent on both platforms developing this honeycomb view. All of our developers hate this thing because it's so much work and it's so easy to introduce bugs into it. But suddenly we just develop it once, and by magic, it just appears on web. So that to us is awesome. And you can see that like the design is pretty much the same. Slightly different data there. I think the Wi-Fi is a little bit slow. But you can see that the transitions are as smooth here as they are here on the web, and that the design is exactly the same without any extra work. And I think that's like really impressive. So that is the actual React Native Web, but let's have a look at Storybook as well, because I think that's quite an interesting point to see too. So this is our component library, and you'll be able to see that we have a web version of exactly the same thing. Let me just move this around a bit. So you can see that, again, it looks exactly the same way, and that enables us to actually take components from native, share it with the whole company, and without losing any credibility. I actually originally thought that maybe the designs will be slightly different, but in reality they are they are pretty much exactly right. I guess that's because we can reuse the styles easily. I'm not really sure how React Native Web does it. Honestly, to me, it's like magic, but it means that we can now go freely from one platform to the other and not have any issues. So that is actually what we have decided to do. How to share code between platforms is by using React Native Web. And just a few tiny things for the end. Sharing code does speed up development, and it decreases costs, and everybody loves it. It also introduces a lot of headaches for developers. As any abstraction, as any way of us always trying to be smart, it introduces problems that we didn't anticipate originally. But that's okay, because there are ways of dealing with it. I would recommend, if you want to go this route, to use monorepo for your web and React Native apps. It's not a particularly easy thing to set up. One of the problems is that there are no build tools, like build pipelines for it readily available, so you have to write your own. But it is definitely easier than trying to somehow share dependencies. What I would, however, recommend is using React Native Web, because that is the most powerful and easiest way around it. It is not completely free. You have to still do some extra work, but it is really smart. And last but not least, design systems are really cool. Every company should be using them, and React Native Web can really help you there if you're working with React Native. And that's everything from me. Thank you very much for your attention.
This video recording was brought to you by Twilio. We allow you to integrate different means of communication such as video, chat, or SMS into your React applications. If you want to learn how you can send SMS directly from a React chat, check out this video on the right or go to our Twilio YouTube channel. And if you want to watch another React India talk, we picked one out just for you over here on the left. Thanks for watching.